Hi everyone, it's Mike Heydrich. I'm going to walk you through wiring a Baileigh Magnetic Brake. So Baileigh, in their infinite wisdom, when they released their magnetic brake, decided that the incoming voltage needed to be plus or minus 10% of exactly 220 volts. And I'm not aware of any single-phase power in the United States where the voltage coming into the house is only 220 volts. Everything is 240 volts or above. So in order to get this wired up and not run the risk of blowing the electronics, they want you to buy a buck boost transformer, an auto buck boost transformer. So they're charging about $325 as of 2020 for this transformer. But that's not necessarily needed because we have other options rather than the one that Baileigh sells. So do what you want. If you want to buy one from them, that's great. But I bought a used brake and I didn't want to spend $325 on the transformer. So looking at transformers, SquareD makes options for us. And on the internet, if you do a search for SquareD transformer, so I can focus in on this without too much glare. Schneider Electric has a calculator for figuring out exactly which model and how to wire it for their buck boost transformers. So buckboostcalculator.com/indexcfm will take you to the Schneider Electric page. And what's important is you plug in specifications. So single phase power, I put the available voltage at 241 volts. Voltage change was 10%. That's about where I wanted to be. I'm going to do what's called buck voltage, which is lowering the voltage by the 10% percentage, which takes me down to around 219 volts with a load current of 15 amps. So when you run the calculator, you get a couple options on things that you can run. And one of the options is the 500 SV 430 or 43B. And you've got two different wiring diagrams that you can use. So I chose to use wiring diagram 4, again for model 500 SV 43B. Once I knew what that was, I started looking for that transformer. And I found one for under $100 on eBay that was brand new. So this wiring diagram has a high voltage and a low voltage side, and then all 8 of the wires that come in the transformer. So if we look at this, low voltage 1 and high voltage 1 and H1 get connected together. H2 and H3 get connected. Low voltage 2 and H4 and X1 get connected together. X2 and X3 get connected together, and X4 and HV2 get connected together. So we have 5 connections that we have to make in order for this to happen. So I'll come over here to my current setup, and let me turn on my voltmeter. All right, and so my incoming voltage not easy to do in a plug. Measuring at 245.1 volts on this current reading. So that's exactly what I was saying, that you're always above 240 volts in the United States. So I've already made the wiring connections. This is the box for the buck boost transformer that I purchased. Again, 500 SV 43B. And let me go ahead and power this up. I've wired the connections already on the magnetic brake. And we'll measure them again now that those 5 connections are made. Here, we'll move this out so it's easier to read. So we're at 221.5 volts, running it through the buck boost transformer and buck voltage setup. And again, that's making those 5 connections. As you can see down here, here's the 5, there's 2 exposed that I was just measuring, and then the other 3. So that's a way that you can purchase a buck boost transformer and wire it up, and as long as you measure your voltage before you start researching which model to purchase, do the calculator, purchase that, and then wire it like Schneider Electric tells you to wire it, you can get within spec. So this particular magnetic brake needed to be under 231 volts in order to operate within their specifications. So I'm at 221, which is about perfect to try and get you at the 220 voltage that they spec. So this is Mike Heydrich, trying to help you get your magnetic brake wired and not break the bank doing so. Thanks.